I've just done it really just to show that you can have a go at doing this yourself. All the stuff made, all the containers, the light box and everything are all sort of homemade, so it just gives you an idea of what you can do. But obviously you can buy the whole lot as well, or you could go to a printed circuit board manufacturer. This produces a thing called a Gerber file. So once I've produced my prototype, got it debugged, got it working, then I send it off to Belgium or wherever as a Gerber file on the internet, and they send me back a beautiful printed circuit board. But obviously they charge for it, but it really is a nice board that they send back. So that's the way it works.
Richard, so the program knows about like them displays. It knows how big they are.
Yeah.
That's how it builds up the thing. Does that come? Do you have to buy extra when you buy the program?
No.
Do you have to buy extras?
No, you can design your own, and it's quite easy to do as well. So, for example, when I bought an Easy PC, this particular chip is a PIP
package.
Yeah. Yes, it's a 690. Now that didn't exist when when this library was made. But basically, what you do is you choose. First of all, you start off with your schematic, and you design that. So what you do is it really is just a box. And with and you basically allocate the names to each of the pins. So you'd call pin 1 would be VCC, RA5, RA4. You just give them all the names. So you do that, and then the next stage is you then design the actual component itself. And this you because you can blow the zooming and scrolling. When you're actually designing the chip, it's very easy to put up, using if you press I think it's the O for origin key, and then as you bring the cursor down here, it's telling you exactly where you are. And what I do when I'm designing a new chip or something like that is just use that to measure the pads and the distance. So choose something that's pretty similar to start with, copy it, and then and then you can just alter it, and that's what it is. And I find that very, very accurate as well.
So once it's done its bit, you could literally grab hold of that chip, drag it around, and the circuit and the program would sort of move the tracks to suit it. If you drag that down,
sort of.
Ideal.
As I say, it's a £400, but you can see
that kind of thing.
Yeah, it's not very good. It does have its limitations. But one of the things you can do, let's say I did that, so I pull that down. We can see there's some tracks that are shorted out now. If we do the design rule check, then it's going to check a whole load of things for us. At the moment I've only got a few ticked, so it's going to check tracks and pads and wires against the circuit diagram that we've produced on the other screen. And if we run that, then it's going to it tells us a whole load of errors that we've got there, and it actually shows you where the tracks have been shorted out. So obviously it's very easy to make a mistake, because you could just be moving something and it's shorted some tracks out. So if we put it back again now and then run the same design rule check again, then we get no errors found. So there's some quite nice error checking in it, and I find it okay. I'm sure there's probably better ones around now.
Does it know the difference between signal tracks and power tracks and things like
that? Yes, it does. You can set in. They have these things called technology files, and you can say, right, your power tracks are 50 thou, and your signal tracks are 20 thou, and then you can have a sort of upper limit and lower limit, and it will decide, oh, I can't really use that track. I'll have to use a thinner track, and it'll actually use it for you. So But no, I found you know, designing your own chips was no problem really, rather than sort of waiting for somebody else to design them. Right, is there anything else you want to know before I run the video? It's
you say you send them off to get it made.
yes.
Yeah. Those resistors look like surface mount ones. Do they put those on for you, or
No, I put those on.
you just put one
For
yourself?
this board here that I've done, we haven't made them later. And there's surface mount resistors and transistors on that board.
Yeah.
When I first went into management and software, and when I came back again, of course, all the chips I say had changed, and I thought I'd never going to get to be able to solder these surface mount microprocessors and things like that. And there was a talk at a club, and this guy was showing us how to do it. And it didn't look quite as bad as I thought it was going to be. And I made some tools for holding the resistor on the board. It's basically a peg with a pin going through it, and as you open the pin, it moved the pin. Open the peg, it moved the pin up, and then it held the resistor in the right place. You've got two hands then to solder either sad of it. So that was good. That seemed to work okay. But then you come to this. I mean, these are huge. Those are big. Those are big pads. Those compared with normal microprocessor ones. So you get to think, well, you know, you solder that one, that's not too bad. And then these start to maybe, you know, you bridge them. And you don't worry, you just go solder, 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 and then you get some solder wick, and you just stick it on, and just pull it down, and it sucks all the solder out, and makes all the shorts, and then you're left with a nice board. So that's something you learn. It's just like everything else, there's tricks and bits and pieces that you learn. The only thing that is a pain is the non-leaded solder, and that is difficult to use, I must admit, with surface mount. I use a company in Horton Wood who do my printed circuit board building, you know, for production side of things, and he has to obviously use non-leaded solder, and it really is awful to use. He hates using it. But that's the way it is. You can't use lead anymore. So, but for prototypes, it's all right, but not for production work.
Are yellow holes through plates or pins?
These are obviously, when I send it away to be made, they're vias, and they do it. I tend to, and again I'll show you this later. If you notice, there are actually no tracks on the front of the board.
Yeah.
What I do is I use it's like a self-fluxing red enamel wire, and what I do is I just make those vias bigger than they should be, because normally they'd be about a third the size of that, even less. Those give me the pads, and then I just using the enamel wire, I just join them up together. Two reasons. First of all, the pins can be so, you know, this is wide, this is all big, this just to show you, but if you imagine that was a third of the size and you've got something right next to it, first of all you've got to line the two sides of the printed circuit board up together, which is no mean feat. Then you've got to etch both sides, and you could finish up with one being good and one being bad, and then sod's law, you do it again and it's the other way around, one's good and one's bad. So I've just taken the view for doing prototype work. I try to get as many tracks, which are the copper ones on the bottom, if you like, and then as few on the top, and then I just wire them up. And it's just, you know, that's what I've just done. I'd get so cross, I think, by trying to make a double-sided printed circuit board. I'd probably just give up and send it off to be made. But for a prototype, that's the way I do it. And the other thing, because they're quite big, these things, you know, if you had a printed circuit board made and there were bugs in it, you know, there was shorts or whatever, it's so much easier to be able to just lift a wire off. You know, there's something wrong here, I don't know what it is, I'm getting some problem. It could be something there, it could be that, could be that. Now I just lift the wire off. Oh, it's stopped, it's okay now, so it must be something up here that's wrong. If you've got a printed circuit board made, you're sitting there with your scalpel, cutting through tracks, trying to work out what's gone wrong. So that's what we do. Right.
How much did you say? How much does it cost for a board like that size to be printed?
Well, I had some about twice as big as that made. I did a DDS unit, digital data synthesizer, about twice big. So you're probably talking about £10 or something like that for a board.
Okay.
Yeah, but you've got to buy them in a quantity. You know, you've got to buy probably 20 boards for that price.
Oh,
If you've only got 2, then it's probably 100 or something. But I was just saying before now, 7 years ago prices were expensive for 1-offs and 2-offs. Now they seem to be getting a bit cheaper now. Right, shall I run the video? So it's a bit sort of tongue-in-cheek this, but I hope I just want to show you what you can do on your kitchen table and see what you think. My name's Richard. I'm going to spend the next 10 minutes talking about how to produce a reasonable quality printed circuit board. Just go through the equipment first. The first thing we've got is a homemade light box with 2 ultraviolet tubes in it. We've got an etching tank, and we're going to heat the chemicals up using water and the heater that you can see there. We've got some ferric chloride, and we've got some sodium hydroxide, which is the developer. So that's going to etch the board, and that's going to develop the board. We've produced a film of the printed circuit board that we're going to use. That was done on an inkjet printer. Probably better to do it on a laser, but it's come out quite well. We've got the photosensitive printed circuit board ready to be etched and developed, and a piece of glass just to keep it all flat. I'll show you that in a minute. And a couple of trays to develop and wash the printed circuit board. So the first stage is to expose the photosensitive printed circuit boards using the ultraviolet light and the film. It's important to put the ink side actually against the board, otherwise you won't get a nice sharp edge to the printed circuit board itself, the tracks, and they could be blurred slightly as well. So we put that onto there and just slide that underneath the ultraviolet. So we're now going to switch the ultraviolet lights on, and we're then going to time it for 2 minutes 25. I'll switch them on and then start the timer. So when that's finished, we'll come back to you in a minute. So we've exposed the printed circuit boards now for the requisite time period, and we're now ready to develop the board. So we take the piece of glass off, and the film, and then there's the board that's unexposed, to keep the negative safe from dirt and everything else. Okay, so if we now pour the developer over the printed circuit board, and you might be able to see very quickly you can see the outline of the tracks, and the excess resist is then washed off with the developer. It's important not to rush this too much, because if you leave a bit of the resist on, the copper won't etch away. So I'll just have to push it backwards and forwards. The other thing is, I used to try and reuse the developer, but now I find it's best to use new developer every time in a smaller container. So you only need a drop. And you can see now it's nearly done, but not quite. There's a bit at the bottom still that still hasn't done. So as I say, once you think it's done, just give it another 30 seconds just to really finish it off. We've developed the board now, and we've given it a good wash to get the developer off, otherwise it will continue to eat into the board a bit. The etchant's now been heated up to about 40 degrees centigrade, so I recommend it's done indirectly, because I had a nasty experience once where we'd got an aquarium heater directly in the ferric chloride, and the ferric chloride got into the heater and it exploded, and hot ferric chloride went everywhere. So good idea to do it using water. Okay, so that's at about 40 degrees now. It can be a bit hotter if you want, maybe up to 50 degrees. Right, so we're now going to dip the printed circuit board into the tank. You can use a bubbler to bubble air past it, which will get rid of the dissolved copper, but I just tend to use a piece of fishing line and just jiggle it up and down inside the liquid. So off we go. Usually takes about 5 minutes to do this. So when we get a bit closer, we'll come back to you. So it's about finished now. So we'll take it out of the hot ferric chloride and put it straight into some water to stop it continuing to etch. Give it a good wash. So that's the board, the finished board. You can see the tracks on the left-hand side are quite narrow. They're only about 1/8 of an inch across. The surface-mounted chip is a reasonably large one, but you can see the tracks are quite fine. So you could do a lot narrower pitch printed circuit board if you wanted to. So the next stage now is to drill the board, ready for the displays, 7-segment displays to be mounted onto the board. Right, that's it. So as I say, there's an example of the board. Let's just have a look at it. Put the lights on in a minute. And this is as I say, the final the digital voltmeter itself, and obviously connected to measure some voltage if you wish. And the final bit of it was when you've produced a copper board, obviously it does tend to get a bit corroded and oxidised. So for the first time I used some of the tin solution on it. I was quite pleased that it made quite a good job. Quite easy to use, so you just dissolve the tin salts in water, drop the printed circuit board in for about 10 minutes or something, and it doesn't do a bad job, and obviously keeps it nice and clean. Right. That's me. So any questions? Just
I I noticed that one's still got the photoresist on, you haven't tuned it. Do you ever just leave photoresist on?
You can do, yes, yes. I tend to leave it till the last minute, you know, and then put them, you know, take the resist off. But you can actually solder with the resist on. It does make it a bit messy, but it's not a bad finish, is it? It's quite a smooth finish on it.
If people were starting wanting to do a circuit board and they had literally nothing, I mean, you'd have to go out and buy the drills as well, which is
well, that's those. I think I drilled those at they're 0.8 of a mil. Yeah, and I actually, because when you actually these holes here, what they actually make, obviously when it's etching, you get the copper there, and then you get a little tiny pip in the centre.
Yeah.
And it's amazing, because my eyesight isn't brilliant. I just use a Black & Decker drill in a stand, and I sort of, you know, that's about right. And so long as you're not too far away, it'll actually pull it into the hole, and it'll drill it absolutely spot centre. Without any problems.
what kind of companies supply stuff like the circuit boards?
I think all that was from Farnell. So they do everything you need. All the chemicals with Farnell, the developer, the ferric chloride.
Send them through the post.
They do.
They do.
It's a solid.
Yeah.
They're like sort of little tablets that you get. But yeah, they did 7 years ago. So yes, everything was from them. There are other ways of doing it, but as I say, the problem these days, if you want to use the modern chips, they're all surface mount. You can, in the old days, you'd lay it out on with tape. That's how I first started. So you'd have this sort of rather, it was sort of like probably, I don't know, what it would be about an eighth of an inch or something like that, yeah. And you'd lay it out, and it was sort of springy, this tape. I don't know what it was, like crepe it was, and you could bend it. It was really weird. So you could do all these very, very nice little shapes and things like that using this tape, because it sort of stretched. But after about a year, you'd sort of do this beautiful board and come back to it, and the tape would have shrunk, or bits would have fallen off it, or something like that, you know. So I must admit, I've embraced the photo technique more than laying it out with tape, but that's another way of doing it.
Thanks, Richard.
Okay.
Pens too.
Well, say, have a look at that.
Pens. Have you made them with pens? You can just paint on your tracks.
Yes, you can do that as well. Yes. But again, you know, you really have to, you know, you're probably bringing it down to something like that, and then you're trying to do these sorts of things here and to surface mount. It's okay with biggish components, but for small ones, it's you know. I would recommend the photo technique, certainly. You see, I put a little note there on this because I've forgotten to put the 5-volt regulator on it. So I've just put a note on there to remind me to put it on next time I do a mod on it.
If somebody wants to do this, what software? I mean, they can't. £400 is a bit steep, isn't it? But
yes, as we said before, there are free versions of these things. There's a free version of this, but it's got limited connectivity. It doesn't have the auto route in it, things like that. But
I think we said we'd be interested to hear about a Linux.
There is a Linux one. I haven't tried it, but the VN distro has a package called PCB. Depends on areas of the packages. I think it works. I think it produces JAVA files, but I haven't tried it.
Yeah, sure it does. Yeah. But as I say, I was sort of started this company, and I wanted some support as well, because I didn't want to start faffing around for days on end trying to sort something out. And the help desk was particularly good. And I must admit, you know, if you're doing it for a business, then you want something that you can get good response back. If you're just doing it for a hobby, that's a different matter.
Thank you.
Okay, Andrew?
Thanks so much.